We're going to do the experiment. Describe the experiment. What are we doing?
We're going to drop a Snuggie and a book, and the book is heavier, the Snuggie is lighter.
Okay, so which one do you think will hit the ground first?
This one! Oh, I saw some leaves fall.
Yeah.
This one.
Okay, so you ready? Let's do the experiment.
Yep.
The count of 3. Ready? 1, 2, 3. Alright, before we finish watching the dramatic conclusion to that video, I'm going to introduce the rest of this video. It is all about free fall, things that are falling near the surface of the earth. By the end of this, you will be able to explain the conditions of free fall and apply the acceleration due to gravity to solve free fall problems. It was Aristotle, almost 2,000 years ago, who said heavier things fall way faster than light things. I might be paraphrasing a little bit, but he was a genius of geniuses. The man made tremendous contributions to philosophy, to science, to politics, to just so many different areas. He was a tremendous influence, and his ideas persisted for almost 2,000 years. And one of the big ideas was that heavy things fall faster than light things. Well, enter Galileo around the 1600s. Here's a picture of him as an old man that you're probably familiar with seeing Galileo like that. But when he did some of his more relevant scientific work, he was probably a younger man. And he did a famous experiment where supposedly he dropped 2 balls from the top of the Leaning Tower of Pisa, and and these 2 balls were very different in weight, although they were the same size. But one of them was much heavier than the other. And he came to the conclusion, in reference to Aristotle, that heavy things do not fall faster than light things. All objects fall with the same increasing velocity as long as their air resistance is not a factor. Now, again, I'm paraphrasing here. But this man is considered the father of modern science. Because unlike Aristotle, he decided if we are going to come to conclusions about nature, that we have to actually do experiments. For Aristotle, doing experiments was below him. But Galileo believed, rightly so, that if we want to understand nature, we have to actually conduct experiments to see what the results are going to be before we come to conclusions. So let's finish watching that video now and see if Galileo was right. 1, 2, 3. Which one hit the ground first?
They hit at the same time.
They hit at the same time. Does that surprise you? So yes, Galileo was right. We need to conduct experiments to see if heavier things do fall faster than light things, and they don't. If we are able to take air resistance out of the equation, then on the surface of the Earth, neglecting air resistance, everything falls with the same acceleration. We call this free fall, which is the downward movement under the force of gravity only. We call this rate at which things increase in velocity an acceleration due to gravity, and it has a value of 9.81 meters per second squared. 10 meters per second squared is a very good approximation. So what does that mean? It means that objects fall at an increasing velocity of 10 meters per second every second. Let's look at this example. Here we have a dropped ball. Any dropped object will have an initial velocity of 0 if you're just letting it go, or if it rolls off a shelf or something like that. So at time equals 0, it has a velocity of 0. 1 second later, it's going to have a velocity of negative 10 meters per second. Why negative? Because in typical physics convention, down is the negative direction. So if an object speeds up at 10 meters per second every second, and that means after 1 second it's negative 10, after 2 seconds it's negative 20, after 3 seconds it's negative 30, and we can just use this equation to figure out what the velocity is at any time. again, with the initial velocity being 0, we can just ignore that term and use this equation. So after 4 seconds, an object in free fall would have about negative 40 meters per second, using that approximation of 10 meters per second every second. What about position? Notice we have increasing position in subsequent seconds. Why is the position increasing? Because the velocity is increasing. Let's take a look at the delta x equation, equation 3. Again, we can get rid of this term because the initial velocity is 0, so we have delta x is equal to 1/2 gt squared, and this is for a dropped object. Initially, the position we'll call 0. After 1 second, it will have fallen 5 meters, then 20 meters, then 45 meters, and 80 meters. I should have had a negative sign in front of the 20 and the 5, because since down is a negative direction, it is getting a negative displacement. So here's a strobe light, a student dropping a ball, and the strobe light flashes 12 times per second. So that means we have an equal amount of time in between each flash, and you can see that the ball, as it's speeding up between each subsequent flash, is falling further and further. Alright, so let's do a sample problem. Here I am doing a bungee jump. This was my honeymoon weekend with my wife. We were traveling down south, and we came across this great place called Pigeon Forge that had go-kart racing and indoor skydiving and bungee jumping, and I had to do it. So I climbed a tower that was over 6 stories tall, and my question is, what is my velocity after falling a distance of 8 meters, which was about halfway down? And how long did it take me to fall? So I do my VFW, of course. Acceleration is equal to g. By the way, I didn't talk about this before, but the acceleration due to gravity gets its very own special variable because it is the same everywhere on the surface of the Earth, neglecting air resistance. So the acceleration is g, which is 9.81 meters per second every second. Delta x equals 8, so I've fallen 8 meters. My initial velocity is 0, and the question is, how fast am I going after I've fallen 8 meters? So which equation am I going to use? You look through your list of kinematic equations, you realize, of course, you've got to use v squared equals v0 squared plus 2ax. I do the work, and I get something along these lines. So v is equal to 12.528 meters per second, and I apply sig figs to get a final answer of v equals 13 meters per second. And because I'm heading downwards, and downwards is the negative direction, it's a negative 13 meters per second. So negative 13 meters per second, I'm going to let you try to figure out the time on your own. Again, list out your variables, figure out which equation you're going to use. You should be able to get 1.3 seconds. It will take me 1.3 seconds to fall 8 meters. Now, what if I throw an object up? At time equals 0 seconds, let's say it had a velocity of 39.24 meters per second. It's going to lose 9.8 meters per second every second. So the velocity would be changing like so. So whether the object is going up or down, it doesn't matter. It is going to be gaining 9.81 meters per second in the downward direction. So we'll be getting into more complicated problems like that. But in summary, free fall is a downward movement under the force of gravity only. So this is on the surface of the Earth, and we're neglecting air resistance. This is called acceleration due to gravity. It gets its own special variable, g, 9.81 meters per second every second, and 10 meters per second squared is a very good approximation.
Paper and a book, and we're going to do the same experiment. Okay, ready?
Go.
1, 2, 3, go. Whoa, the book hit the ground first, definitely.
I know. We look stupid. Let me try this.
Let's do the experiment again, but this time crinkle up the paper.
What
Crinkle it up into a... Okay, ready?
Go.
1, 2, 3, go.
They did it at the same time.
Crazy.
Wow. Whee! catch.
All right, say goodbye.